Lesson 10, linear inequalities. So an inequality is a statement in which one value is less than or greater than another value. So you've seen these symbols before. So there's the standard one, greater than, less than, greater than or equal to, or less than or equal to. So up here, you have trouble remembering use to like 5 is greater than 3, right? The 3 is eating the 5, right? Some people use it as the Pac-Man or alligator. 3 is less than 5, right? So you see examples like this in the real world all the time. For instance, you got a parking sign here. So define our variable t equals time. And in this case, 30 minutes is the max. So it could be less than or equal to, right? You could go up to 30. You can't go over 30, but you could go less than 30. Time frame wise, you could say between 9 a.m. and 6 p.m. So t, right, 9 a.m. has to be less than or equal to t or less than or equal to 6. Again, you could start right at 9 and go to 6. Speed limit. S, define our variable as the speed. So S has to be less than or equal to 55. You can go slower than that. You can go 55. You just can't go over. H for height, you must be at least this tall. So H has to be greater than or equal to 102 centimeters. Can't be less, but it could be equal to. Temperature, store at temperatures below 4. So now this doesn't say at 4, it says below 4. So T for temperature, T has to be less than 4 degrees Celsius. Canadian video rating, age for A equals age. A has to be greater than or equal to 14 to watch the movie. Okay, so let's graph these things out. So flip the page. Now to draw an inequality, when you have greater than or less than, it's an open circle. When it's greater than or equal to or less than or equal to, it's a closed circle. So we look at this one. A is greater than 3. So it doesn't include 3. So we owe an open circle at 3, and then it's everything to the right of it. B is less than or equal to negative 5. So it includes negative 5. So negative 5, you can have a solid circle, then everything to the left of it. And you can do this in fractions too. Now, sometimes fractions are a little bit harder to put on a number line, so you can change it to a decimal to get a kind of a general idea of what it looks like. So negative 25 over 3 is negative 8 and 3 repeater, or negative 8 and 1/3, right? Negative 3 repeater is 1/3, just like it was negative 6 repeater, or sorry, 6 repeater, 0.6 repeater, it would be 2/3. So again, it doesn't include this point. So about 8 1/3, we have an open circle and everything to the right of it. All right, go to the third page now. So when we solve linear inequalities, addition and subtraction is the same as it was when it was just an equation. So 7 is less than 9. So if you add 2 to both sides, right, 9 is less than 11. It doesn't change the inequality. Same as if you subtract. 7 grams is less than 9 grams. If you subtract 3 grams from both sides, 4 is less than 6, still the same. It hasn't changed at all. So when the same number is added or subtracted from each side of the inequality, the equality is still true. The sign remains the same. So then you can do it to solve an equation. So 6.2 less than or equal to x minus 4.5. The key is getting x by itself. So to get rid of the negative 4.5, we do the opposite. We add 4.5 to both sides. So we end up with 10.7 is less than or equal to x. Or if you don't like it written that way, a lot of people like the x on the left-hand side. You could do x is greater than or equal to 10.7. All you got to remember is you see how it's open facing the x here? Then it's going to be open facing the x here, right? Open facing the x, open facing the x. And then you can put it on a number line. So you can have your number line, you set it not always to 0, have to be in the center. You can set your number line to any scale as long as you're consistent. If you go up by 1s, go up by 1s. If you go up by 2s, go up by 2s. So 10.7, we put a closed circle there and everything to the right of it. All right, page 4. We have x plus 5 is greater than 2. So we got to get x by itself. So the opposite of adding 5 is to subtract 5 from both sides. So we end up with x is greater than negative 3. And this is already nicely done. X is on the left-hand side. We remember it's an open circle because it doesn't include negative 3, and it's everything to the right of that one. Okay. K plus 8 is less than or equal to negative 13. We got to get k by itself, so we have positive 8 there, so we do the opposite. We subtract 8. Subtract 8 from both sides, we end up with k is less than or equal to negative 21. Number line, solid circle because it includes that point, everything to the left of it. 2 is greater than x plus 7. We got to get x by itself, so we have positive 7. So subtract 7 from both sides. So we end up with negative 5 is less than, or sorry, negative 5 greater than x, or x is less than negative 5. If you want to flip it around, number line again, open circle at negative 5 because it doesn't include that point, and it's everything to the left of it. Q minus 2.5 is less than 3.9. We got to get q by itself. It's negative 2.5, so we add 2.5 to both sides. So we end up with q is less than 6.4. So if you look at this number line, this is interesting. I went up by 0.1, right? So 5.9, 6, 6.1, 6.2. So that makes it really easy to graph. Open circle at 6.4 because it doesn't include that point and everything to the left of that. All right, page 5. Now, when you're solving linear inequalities with multiplication or division, the rules are slightly different. Now, let's take a look at this. So if we have -2 is less than 2, which is true, let's say we times it by +2 on both sides. So times +2. So -2 times +2 is -4. +2 times +2 is +4. -4 is less than 4. Okay, does that work? Yeah, it works. Okay, now let's divide by +4 and divide by +4, both sides. So -4 divided by +4 is -1. And -4 divided by -4 is +1. Is that still true? Is -1 less than 1? Well, yes, it is. So here's the point being. If you multiply or divide by a positive number, the inequality remains true. So if you multiply by +2 or divide by +2, if you multiply by +1/2 or divide by +1/2, the inequality stays true. So let's look at an example here. So 2x is less than 6. We got to get x by itself. So we divide both sides by 2. These 2's reduce down, so you're left with x by itself. 6 divided by 2 is 3. So x is less than 3. Put it on the number line. +3 here, open circle, because it doesn't include that point, and everything to the left of it. Okay, page 6 there. Okay, now, let's go back to our inequality. -2 is less than 2. That's true. Now, what if we multiply each side by -2? So -2 times -2 is +4. +2 times -2 is -4. 4 is less than -4. Is that true? No, that's not true at all. Huh. So to make it true, what we got to do is we got to flip the sign. So now 4 is greater than -4. That's true, right? 4 is greater than -4 is true. Okay. So let's try doing this again. Let's divide by -4 this time. So 4 divided by -4 is -1. -4 divided by -4 is +1. Is -1 greater than 1? No, it's not true again. Oh, okay. So to make it true, what we have to do is we have to flip the sign. So -1 is less than +1. Okay, so here's the rule. When you multiply or divide by a negative value, you must flip or change the inequality sign. That's the rule. Only when you multiply or divide by a negative, you switch the inequality sign. So let's look at the example here. -2x is less than or equal to 6. So we divide both sides by -2, -2. So we end up with x is, now it would normally be less than or equal to -3, but we have to. The rule is you got to flip the sign. So now it's x is greater than or equal to -3. So when you multiply or divide by a negative, the inequality switches. Okay, so then we do our number line here. We have a closed circle at -3, and it's everything to the right. Okay, last page is just a bunch of different examples here. Let's go through these. So we have -5s divided, -5s is less than or equal to 25. We got to get s by itself, so we're dividing by -5 both sides. So we know we have to flip the inequality. So these reduce down, so we end up with s is flip the inequality greater than or equal to -5. Put it on the number line, close circle at -5 because it includes that point, and then everything to the right of it. Okay, let's do this one here. 7a is less than -21. We got to get a by itself. So what do we divide by? We divide by 7. Now we're dividing by a positive. Even though the -21 is negative, doesn't matter. We're still dividing by a positive. So does the inequality direction change? No, it doesn't. So a is less than -3. Again, put it on the number line, open circle at -3, and everything to the left of it. Okay. Oh, y divided by -4 is greater than -3. So in this case, we got to get y by itself. It's y divided by -4. So what we do is we multiply both sides by -4. And if you remember, we put everything on the top left, not the right, because we don't want it to look like an exponent. So -4 and -4. So we're dividing by a negative. So the inequality has to change direction. So these reduce down. So you end up with y is greater than -4 times -3 is 12. So we end up with y is less than 12. Okay, remember we changed the inequality. Put it on the number line, open circle at 12 because it doesn't include that point, and it's everything to the left of it because it's y is less than 12. Okay, k divided by 3 is greater than or equal to -2. We got to get k by itself. We were dividing by 3, so we do the opposite. So we multiply both sides by 3. Hey, we're multiplying by a positive. Does the inequality direction change? No, it doesn't. the 3 is reduced down. So k is greater than or equal to 3 times -2 is -6. So we have k is greater than or equal to -6. Put that on the number line. Solid circle at -6 because it includes that point, and it's everything to the right of it. Okay, so now you can work on practice number 10.